The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
Alright, so now I'm going to work through problem number 5 in the Physics 2020 Midterm Exam 1. And in this particular problem it says, what is the acceleration of a car that travels on a straight road from rest to 75 kilometers per hour in 8 seconds? Alright, so we are trying to find the acceleration. Okay, we want to find acceleration, so we want to know what is the acceleration if we A. And we know that the car is traveling on a straight road from rest, and so that implies that our initial velocity is 0. Okay, because it's not moving, so it doesn't have initial velocity when it's from rest. We know that the final velocity, V, is equal to 75 kilometers per hour. And we know that the time, our time frame that we're dealing with is 8 seconds. So we want to know what the acceleration is, and in this particular problem, it doesn't specify the units of our acceleration. But if we look at the answers that are given, the only units that we have available are meters per second and kilometers per hour and alright, so we have meters per second squared. We have kilometers per hour squared, and we have kilometers per second squared. Okay, so here are our units that we need to choose from. Okay, and this is a bit of just trial and error, but let's just assume that we want to find the answer in meters per second squared. And so we know that if we look at our formula sheet that's given for this particular class or this particular exam, says that our acceleration is equal to the change in velocity over the change in time. Okay? And we know that the change in velocity is equal to the final velocity minus the initial velocity, and the change in time is equal to the final time minus the initial time. Okay? So, we know that the acceleration is equal to the final velocity, which is 75 kilometers per hour, minus the initial velocity. Well, we know that the initial velocity is 0, divided by the final time, which is 8 seconds, minus the initial time, so that's time 0. Alright? And since we have time in the numerator that's expressed in hours, and time in the denominator that's expressed in seconds, we need to convert one of them in order to calculate this answer. And so we can simply do that. So we've got 75 kilometers per hour multiplied by 1 over 8 seconds, and let's just move this over here. I got a room. Okay, and so know that we want to convert to meters per second squared, and we know that in 1 kilometer there's 1,000 meters. We can also get that from the formula sheet. And we know that in 1 hour there's 3,600 seconds. So this hour will cancel out with this hour. This kilometer will cancel out with that kilometer. And what's left is meters over seconds times seconds, which is seconds squared. And if we calculate this, we actually get 2.6 meters per second squared. And if we look at our available choices for the answers, it shows that we have 2.6 is one of the available answers. So we can assume that there's only one right answer. So this is the correct answer. If we were to do kilometers per hour, then we would have had to convert this seconds into hours. And once we did that, we will see that we will come up with a different answer that's given for kilometers per hour in this particular problem. So most of the time, acceleration is going to be expressed in meters per second squared. It could be expressed in either one of these units, but most of the time it's going to be expressed in meters per second squared. And so if given the choice of picking units, I would start with meters per second squared, calculate the answer, and then if that's not correct, then I would just pick a different time. So this is a bit of a trial and error, but the important thing to know is that you're trying to find the acceleration, and acceleration is expressed as the change in velocity over the change in time. And so you're going to get a distance over time squared, and that's exactly what we got here. We've got a distance which is in meters over second squared. All right.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.